Don't do that.
And on this episode of Think Build Test, we need to do some clearance cuts for our X-frame beam. And I've got a new secret tool that I want to be showing you guys. And we'll do a little product demonstration of this. This isn't going to be a full-on review, but this will be a really good way for you to decide whether or not this meets a good application for your needs or not. So this is, for me, was worth it because having to do inside cuts with an angle grinder is usually really messy and time consuming. So what I have to show you guys today is I have a 120 240 volt plasma cutter. This is a Warfox Cut 50 DP. This is going to be my first time using this for a practical purpose. I have no experience with plasma cutters, but after doing some research, when you get to the 50 amp, then you start getting what is called a pilot arc. To me, the main difference is you don't have to strike this, so that means there's a lot less cleaning of the metal you got to do. Because this provides its own spark, you can cut rusty metal, you can cut painted metal, you can cut greasy metal, but most of the machines that are 45 amps and below are non-pilot arc, which means you have to strike the arc like a welder. But this one has an internal ground in the tip that will start the arc for you. I believe what I've read on this is that it's going to require 40 to 60 psi of air supply, which should be no problem. I've done a couple little cuts on some scrap metal, but this is going to be my first time using this on an actual project. So we'll see how much time this will help us save by not having to overly grind out notches. Currently I'm plugged into 220 with this adapter that comes with it. You could just take and plug this straight into a 110. I have this set up on an old Harbor Freight cart that I used to use for my little Harbor Freight welder. So I have that positioned close enough to my air compressor, so I'll just hook this up. Turn on our main disconnect. Apply our grounding clamp. The power switch is on the back of this, so make sure you leave it accessible. As soon as I start pushing this button with it turned on, then the air will go. And after a few seconds of not using the arc, the air turns back off. So what I've noticed so far is freehanding this can make your lines a little sketchy. If you have a guide to go on, then it really straightens everything out and helps you control your hand flow. I'm going to mark this up and figure out what my clearances need to be. I need to get rid of this tab here, and I need to create an angle cut here. So let's set this pipe up and see what we need. For the end of our beams, we're going to have some clearance notches to make this a clevis to be able to have this wheel to roll in here. Now that we've got our drills drilled like we did on our last episode. So I did a quick little clearance cut so that I could have this wheel in here and kind of look at what we need. But we're also going to have to cut an oval off of this so this end doesn't foul. Let me show you what I'm talking about. For our stationary pivot point, we're going to weld up a secondary clevis to this angle iron, and it's going to have to go here. So as this rises higher and higher, we're going to have to create clearance cuts for this beam across here. And we'll have the same situation for the roller side. We'll replicate the same thing on both sides, and that'll just kind of simplify things, so if we get a beam turned around backwards, it'll be fine either way. I have this beam well above my head, so if we decide to hyperextend this X-frame, we'll kind of know how much clearance we need on that angle. So we'll go ahead and use this now as a reference and mark our clearance cut, how much we need. So there's probably some kind of calculation we could have made if we wanted to engineer this in theory, but that's what this practical engineering is like. We can set stuff up, and before we make cuts, kind of mock things in place. Then we can just solve our own problems by just taking a second, looking at everything, seeing what all's going to happen when things actuate. But then, hey, if there's something else, we'll just cut a little more off, come back to the drawing board. Okay, now that we got this measurement done, I'm going to have to do a clearance cut for this, so I'll just make it the size of my inside bearing. Okay, so what you're gonna notice on this is I have this little guide ring that helps keep your tip flat, and it provides about a 1/2 inch buffer around the cutting surface. So now I need some kind of a smaller guide that's about a 1/2 inch less to do my cutting off of. Now I should be able to bring this around and just keep following that piece of metal all the way through. Now since I upgraded my welding helmet, this has 3 settings. It'll let you just use this for a shield for grinding. It'll go full dark for welding, but there's a middle setting that's just for arc cutting, since it's not as bright of a light. I just switched that to the middle position of cut, and then we're ready to go. So I think we're all ready to cut, but we need to be aware of our surroundings. This is gonna be blowing molten metal down, so we wanna make sure there's no hoses or anything below us for this to ruin. I did create a divot mark where I didn't make this a solid piece, so I may want to look into figuring that out to be a little smoother. All right, so I've created a little round piece with the same roundness of my 1-inch pipe. Now I can take this template I made, clamp my bar in place on each piece, and I'll get something that kind of looks similar. Let's see how it turns out. Okay, well, let's see how that cut looks. It's a little jagged, but doing my notch piece, that went way faster. Let's get the grinder out and see how much it takes to knock this slag off. One thing I don't like about this is that heat kind of caused this to flare out this way. So I'll probably have to tap that in a little bit with the hammer. I'll probably have to come back and kind of work these over with the file, get all the little hard edges off. This angle looks really good right here. This isn't going to be this close right here. It's going to probably be back another 1/4 inch. So probably what I'm going to end up doing is welding a gusset in here. Then that will help give the clevis more strength. This cut over here, I have to finish that one up with an angle grinder because I can't get that heat too close to the side walls or I'll weaken the clevis. It's cutting really good through this 3/8, and typically 3/8 to 1/4 is about the deepest I ever go for most of my metal work. I just went ahead and set the power to max. I have the post time set at 6. My PSI on my air is at like 70, but I do prefer this on a flat piece of sheet rather than having this as a tubing because it makes it real messy on the inside. But like I said, I'm gonna be getting my grinder out anyway for this. I'm gonna finish up doing all the cuts on all these and then I'll give you my final thoughts. I'm gonna come in with the angle grinder real close to the edge. So using the angle grinder cutoff disc gave me a nice square edge, which I need for where that roller bearing is going to roll. So my conclusion on the Warfox plasma cutter is, for a plasma cutter, I don't see anything wrong with it so far. We put in some good hours today using it. I need to get more experience and learn a few tricks and tips with it. But I think what it comes down to is not that it's the Firefox or a better brand, I find that I'd rather use a cutting disc than to use a grinding disc. The grinding is very exhausting and takes a long time. Usually the cutting is precise, get it done. I'm not really liking grinding the pits and the bumps left from the lava slag. So that's just my 2 cents. I definitely see a purpose for it. When you go get in and go sideways in the middle of a piece of metal, definitely can't beat it there, but it's just not a real smooth cut, and you're just gonna have to go clean everything up with a grinder. If you're new to the channel, these pieces are part of an X-frame elevator floor that's gonna go in my pit that I dug this last fall. So stay tuned for that project. It's gonna be really awesome once this thing starts to come together. Make sure you're subscribed, like and comment. It really helps the video a lot, and we'll see you on the next video.